functions and environments in a moment here. Okay, so again, we're going to go to online poll. Go ahead and log in there. Just, of course, the website freezes on me. Okay, your first question. So if you log in and you look at 102A Lecture 1, here I've written I have this set up. So in our global environment, we have x is 0, y is 10, and then I have an f function, I have a g function, and I have an h function. Okay. So if you look at this code here, so the first question, which is the one we are working on, okay, it just says, take a look at function h. Are you guys able to see this? You guys need bigger text here. Let's see, how do we do this? Okay. That's about as big as I can make it where everything still fits. It says take a look at function h, okay? And inside function h, I've got x is 3, and x and y is what the function will return. And so the question is, if I execute the command h, what will this return? Okay. Are you guys all just typing this out because... all right. On test day, you won't have your computer, and you're going to need to be able to answer this question, okay? Without the assistance of your computer. So, well, this is the easiest one because we're not dealing with any of this embedded nonsense, right? It's just h. So you can, for now, you can just ignore the definitions of function f and g. Just look at h. And I'm asking, what will h return? Okay, I'm going to, you guys, I'll give you like 10 more seconds to get your clicks in on the online poll. And then I'm going to close it, okay? Okay, so in 5 more seconds. 4, 3, 2, 1. Okay, I'm going to go ahead and close the poll. Sure you want to close the poll? Yes. Okay. Let's take a look at how you guys responded. Oh, wait. This is not how I want. Okay, wait. Polled responses. You guys wrote E, and indeed, that is correct. So when we ask for H, indeed, it returns 13. So E is correct. You guys got that right? Okay, let's try the next one. Question 2. We'll just have 2 questions today, okay? This will be the last second question of the day. Where is this? Okay, quick poll. Okay, so you have a second question, and now it says, what will G return? Okay, so basically, if you can't, the answer choices are exactly the same as question 1. It's either error 10, 11, 12, or 13. And so if we run function g, so inside function g we are saying x is 2, and now execute function h. the question is what will G return? Yeah, I'm trying to, I just shrink this a little bit. Okay, the answer choices are the same as in question 1. Okay, so just look at the answer choices for question 1. What will G return? An error, 10, 11, 12, or 13. Okay, I'm going to just give you 10 more seconds. Okay, I will close the poll. All right, and let's look at the responses. And okay, great. And the correct answer is also E here. Okay, so if I execute G, it also returns 13. Okay, and then F, which says return, X is 1 and all of this, F also returns 13. Okay. Let's I'm going to change a few things here. All right. Here, I'm going to just get rid of. So I'm going to have X is 2, and then I'll have Y is 100 here. Okay. So inside function G, I am defining X is 2 and Y is 100. H is still going to define X as 3, and it's going to return X plus Y. Okay, so if I ask for what H is, in the global environment, X is 0 and Y is 10. So if I execute H, it returns 13. What will happen if I execute G? Will it return 13? Will it return 103, 102? What do you guys think? Well, let's see. It returns 13. Okay. This you guys are looking perplexed. Okay. The key difference here is we are only calling the function here, function H here. Okay. And so let me EFGH, I call this J, and then what I will do here is now I will inside function J. Okay, so J is similar to G, except that inside J I am now defining a function H. Okay, so here H is being defined inside function J. Okay. Okay. All right, so let me execute it this time. So X is 0 and Y is 10 in the global environment. I'm creating a function J where I've defined a function H in there. And now what would happen if I execute J? 103. Okay. Because here the H is being defined inside the function J, and therefore when I ask for it to return the value of H, when this function searches for Y, it's going to search inside this environment here. When we execute H down here, it's looking for Y here, and the Y goes to the global environment and finds the 10 up here. And even when I execute G, we're only calling H, and the original H is still here, and it's still going to search for its parent environment for the value of Y. Okay, are you guys confused enough? that's what today's lecture is going to be about, and it's going to be about kind of environments and all of this stuff, because it could be, well, it may not be as intuitive. So we gotta talk a little bit about this and how all of this works. Okay, so the environment is the data structure that allows for us to do scoping. Okay, scoping is kind of the idea that if something is not defined inside the function or wherever it is, where does it go to look for that value, right? So, because R is going to just try its best. Other languages like C, it's got very strict rules, and if you don't follow the rules, it's not going to compile. It's going to kick an error. Okay. R, on the other hand, is a little bit more laid back, and it just says, you know what? I'm not quite sure what you're talking about, but I'm going to do my best, and this is what I found. Okay, and so it kind of has a system for how it's going to do its best to search for things, and scoping is one of those things, right? Dynamic typing is another feature of R, right? You can, if X is initially defined as an integer, but then you want to change it to a double or a character, R is not going to complain. It's going to say, okay, just whatever you say, right? So what an environment does is it binds the names to values. Okay, so you can think of the environment as a bag of names, and here we've got the names A, B, C, and D, and here we create a new environment called E, and inside of E we are binding the value A to the value false, the value B to the character A, the value C to the double type 2.3, and the value D to the vector 1, 2, and 3, integer vector 1, 2, and 3. Okay. Inside the global environment, like if you just create these values A, B, C, and D inside the global environment, this is basically what happens in the global environment. We're just binding names to different values. Okay. Every environment has a parent, okay, and that's going to be another environment, right? And so in these diagrams, the pointer to a parent environment is going to be this little black circle, okay? And this is how we implement lexical scoping in R. So if we're inside this environment and we ask, for the value D, and it doesn't find it in this environment, what it does is it goes to the environment, parent environment, and it searches for the value there. And if it doesn't find it there, it goes to the next parent, so on and so forth. And so every single environment has a parent environment, with the only at the very, very, very top, which is the empty environment, which is going to be the kind of the great ancestor of all environments. Okay, so these are kind of the 4 special environments that exist. Okay, so the global environment, this is your workspace. This is where you work. Whenever you create variables at the prompt, you're creating values inside the global environment. Okay, the parent of the global environment is going to be the last package that you attached. So if you attached ggplot and then attached dplyr and then you attached something else, the last package that you attached is technically the parent environment of the global environment. Right? And I know that sounds a little bit weird, but it's basically just defining how R is going to search for values and functions. Okay, the base environment is the environment of the base package. This is kind of like where your base R functions exist. That exists in the base environment, and it has a parent environment, and that's the empty environment. So the empty environment is the most top level environment, the ultimate ancestor of all environments. And then the base environment is directly under that. So the base environment is where you have kind of your base R functions, the functions that kind of power most of your R, and its parent is the empty environment. Okay, and then environment. Whenever you call environment, that's going to be the current environment. if you go to R and you just type into your console the command search, this shows the current search path. Right, so it's going to start in the global environment, and then for me, if it doesn't find something in the global environment, it's going to look in RStudio, then stats, graphics, all the way up to the base environment. Okay, so this is the search path because this is how R is going to search for tools. So this is what the search path looks like. You've got your global environment. Each global environment has a parent. So the parent of the global environment, when you knit R files, is going to be package stats. It doesn't load tools RStudio. When you're working in the console in RStudio, it loads up this package here, right? So so this is how tools like functions like capital view X or something, or it brings up the value up here. This is a function that exists for RStudio, but if you tried to do that inside your R Markdown file, it's gonna complain, right? So okay, so anyway, so and then the parent of package stats would be package graphics and package all of this stuff. And so it creates a search path, and then until it gets to base, okay, package base, which will be kind of our base environment, and then the empty environment. All right, and then every time you load a package, say you do library ggplot or ggplot2, then it's going to insert the that package into here in the search path. Okay. The kind of our most common interactions with environments comes when we are dealing with functions. Okay, and so the environments. It says most environments are created as a consequence of using functions. Okay, and so every function has an enclosing environment, a binding environment, an execution environment, and a calling environment. Okay, so the enclosing environment is the environment where the function was created. Okay, every function has one and only one enclosing environment, and then for everything else, there might be 0, 1, or many environments associated with that one. Okay. So the enclosing environment is the environment where the function is created, and then the binding environment is where the name of that function exists. Okay, for all intents and purposes, when you create a function, a custom function in R, the enclosing environment and the binding environment will be the same. Okay, so if you create a function in the global environment, that will be the enclosing environment, and that will be the binding environment, because the name of the function here, f, is in the global environment, and the function was created in the global environment, okay? Or in this case, h, or whatever we have here, okay? So when you create functions in R, the enclosing environment and the binding environment will both be the same, and it will be in the global environment. It's just when you start creating functions inside other functions, then it won't be the global environment. It'll be whatever environment that function was created in. But in those cases, still the enclosing and the binding environment will be the same. The only time the enclosing and the binding environment are different is when you load packages into R, but we'll worry about that, okay? When you execute a function, when you call a function, it creates an execution environment. That's the environment where all the values and variables are stored during the running of the function. And when the function finishes running, that execution environment poof disappears. Okay, everything that was in that environment just gets destroyed. Okay, and then every time you call a function, the execution environment is associated with a calling environment, which is where you've called the function. So, so technically over here, I have this function g, and inside g I call h, all right? So when h runs, it has an execution environment, and its calling environment is inside the function g. However, h is defined outside here, therefore the h's enclosing environment is the global environment, and its binding environment is also the global environment. It's almost comical how it feels very unnatural at first, right? It's just like, why can't we just have names and everything be simple? And I agree, it should be simple, and this is probably actually the simplest way to have a system that allows for scoping and this is as simple as we can make it. It's just unfortunate every time, you know, it's just a little bit hard, right? It's kind of like when you have friends, and some of your friends have the same name, right? And you're talking to a group, and you say, oh, you know, what about John? And then depending on the context, you in your brain will be able to say, okay, I was talking to John, and if there's only one John in your group of friends that you're talking about, it makes sense, right? Otherwise, if there's multiple Johns, you might have to say, okay, I was talking to John Smith to clarify who is who. Anyway, we have our own kind of lexical scoping going on in our heads when we interact with other people, right? How do you define something like that in your brain? It's quite complex because it requires an awareness of who your circle of friends are, the person you're talking to, and awareness of their circle of friends and whether they have the same context of you or not, and things like that. It gets quite complex. So, you know, we're trying to do something similar in the computer language R, where we can just say run function f without having to say I'm talking about this specific version of f here and here and here. Just run a function of f and it does it. Okay. So anyway, that's why it seems kind of complex, and there's all these 4 different environments, but this is what we have. Okay, so when a function is created, it gains a reference to the environment where it was made. So here I've defined h inside the global environment, therefore the global environment is the enclosing environment, okay? And when you name the function, the environment where the name exists is the binding environment. So in this case, the name h exists in the global environment, therefore the binding environment and the enclosing environment are the same. And again, for all of the functions that you pretty much write, this is going to be the same. Let's take a look at this function j. Inside function j, I define a new function h, okay? This h exists inside the environment j, for j. And therefore, the enclosing environment for this function is the environment where, you know, j is running, okay? And therefore, the enclosing and the binding environment for this particular function of h is inside the j. Is that okay? So that's the enclosing and binding environments. Again, when you do stuff, the enclosing and binding environment's pretty much going to be the same. So here is, we're defining y as 1. F is going to be a function which adds x and y. And if we ask what is the environment where f is, it's going to be the global environment, okay? So f is created in the global environment. So the global environment is the enclosing environment. The name f exists in the global environment, so it's also the binding environment. The distinction, the only time enclosing and binding environments become different is when we are dealing with package namespaces. So if we load different packages, right? And so if you load, say, package dplyr or something, and it's got a function in there that that has the same name as another function, right? Like filter or something like that. How do we keep track of what's happening? And when I call for filter, how do I know I want the function that's inside dplyr versus the filter function that exists in base R? And how does all of that happen? That's all handled by the way R handles the enclosing and the binding environment. So because filter is defined inside the package dplyr, the enclosing environment for filter is the package namespace for dplyr. But then the name for it exists in the search path, which is a little bit different. So anyway, all to say, don't worry about it, okay? If you just remember, enclosing and binding environment pretty much is going to be the same for the functions you write. You'll probably be fine, okay? Unless you start writing packages yourself, then things might get more complicated. Okay, and then when we execute a function, it creates a new environment to host the execution, and that's going to be the execution environment. So here I've created a function h. Inside function h, we're going to say a takes on the value 2, and we're going to return x plus a. And so here we say h is 1, and this is what happens. We call function h, where x is equal to 1. So x is equal to 1. This is our execution environment, okay? So h exists in the global environment. When we call it, it creates an execution environment where the parent environment of this execution environment is h, okay? Inside this thing, we assign the value 2 to a. This happens inside the execution environment, okay? The function runs, it adds those two together, and it takes the value 3, and then back in the global environment, it takes that result and it assigns to the value y, or the name y, okay? And so that execution environment, poof, disappears. There's no longer any trace of x, a, the values 1 or 2. The only thing that remains, the shadow of what they were, is this value 3 that's bound to the name y. Okay. So with a calling environment, when you call a function, it creates an execution environment, okay? The execution environment technically has two parent environments, the enclosing environment and the calling environment. So here, we called h inside the global environment, therefore the global environment is also the calling environment. In this scenario here, h was written in the global environment, so the parent environment is h in the global environment, but because h was called from inside g, g is technically the calling environment, okay? When we do scoping, the rule is to look at the parent environment for of where that function was created, okay? But there are instances where you can tell the function, you know what, when you do the scoping, don't search your normal search path of the enclosing environment, but rather search the calling environment, okay? And that's called dynamic scoping. We will not worry about dynamic scoping in this class, but that option does exist, okay? So over here, when we executed g, and we say, you know, x is 2 and y is 100, and we ran h, okay, so when we called g here, h doesn't look for the y in the calling environment, it looks for the y in the parent environment of 10, and it returns the value 13, okay? If we wanted to use this value 100, we could via dynamic scoping, and we would have to inside the function h, we would have to kind of tell it to use dynamic scoping, and I forget how to do that off the top of my head, but it is possible. But you know, again, things get a little bit hairy and confusing there. Okay, let me. Is this okay? This stuff about scoping and where things are defined and whatnot. Okay, there is some help offered. Okay, in that you can see. Let me just kind of say this as environments and scoping. All right. So what you can do is, if you write a script where you define these things, you can create breakpoints. Okay. And so I can create a click right here, and this will create a breakpoint in H. Okay. And I'm gonna just clear this out, and I'm gonna click source, and actually. Let me comment these out. Okay, so you have to save the script file, okay? And then when you click on the side over here, it creates a breakpoint. And then when you click source, it loads it up, and then it says, you know what? There's a breakpoint right here for H. And what this does is it tells R, when you execute something, when we start to do this, go into that function and let me see what is happening inside that function. Okay, so here I said run H, and then it says we're going to browse. And notice what happened up here in the environment. So in the environment, I have the global environment, and inside the global environment we have X is 0, Y is 10, G and H and J are different functions. But because I've executed a breakpoint and I'm executing the script here, I can actually change the environment to inside H. This is that execution environment, this temporary execution environment that exists only during the execution of the function. Okay, so right now my execution environment is completely empty. And so I would just click next, all right? And so now this has run. X now takes on the value 3, okay? And so we can see that this value 3 exists inside of H. And then if I click next, it returns the value 13, okay? And so this gives us some insight as to you know, what is happening. It says X is 3, now we're gonna do X plus Y, and then we can see how it runs, okay? I can come back over here and I can say, you know what, let's set up a breakpoint at this spot inside X and J, and let me remove this breakpoint. Okay, and I'm running out of time here. But basically, normally when you call a function inside R, it creates the execution environment, it does its thing, and then at the end, poof, that execution environment is gone. You do have the opportunity to actually look inside and see what's happening during the execution of a function itself by writing your script, adding breakpoints, and then when you run your commands, it will pause and you will actually be able to go inside and see what's happening inside the execution environment, which is very useful, especially in troubleshooting. Okay, we'll end here for now, and we'll see you guys on Friday.